Over a couple of weeks, a team of around 10 scientists have deployed more than 50 instruments to record signals related to slow-slip earthquakes. The PULSE project is an important step towards better understanding earthquake hazard in New Zealand and the subduction processes that are happening along the Hikurangi Subduction zone along the east coast. The Pōrangahau region is particularly interesting because these slow-slip events happen approximately every 5 years or so in this region. The last event was triggered in 2016 in November after the Kaikoura earthquake. And so we've been expecting that there would have been a slow slip sometime in 2021, about 5 years after 2016. The slow slip events themselves happen so slowly that they don't produce vibrations and ground shaking. And that means that we can't record them or know that they're happening with normal seismic instrumentation. The only way that we've been able to observe them and map out where and when they happen is by deploying GPS equipment. So these are sensors that sit at the ground surface and record their position, and that can tell us how points on the Earth's surface are moving really slowly through time. So while these slow slip events don't produce any noticeable ground shaking in themselves, they can produce and trigger small earthquakes. So the other type of instruments that we can install are these seismometers, these earthquake recorders. We bury the sensors in the ground and we leave them there for a few months, and they basically record any kinds of vibrations that travel through the crust. When we record these small earthquake signals, we're able to do a much better job of telling where these earthquakes are happening. And that can tell us something about how these slow slip events are changing the state of stress in the crust and how they're triggering the seismicity. These slow slip events do happen on other subduction zones around the world, but New Zealand and the Hikurangi in particular has really been a magnet for world-leading science in terms of slow slip event understanding in recent years. And this is because the Hikurangi is in a really unique setting to be so close and so shallow beneath our feet underneath the North Island. And the observations that we make are much clearer than if we were trying to observe things much deeper down in the Earth. The type of fault motion that we see in these slow slip events is exactly the same as what we see in these large, damaging, tsunami-genic subduction zone earthquakes. And so we want to try and understand that if the driving forces behind these two different slip modes, the slow slip and the damaging slip, if the driving forces are the same, then can we use the much more frequent slow slip earthquakes to better understand how the fault is driven to failure. And this deployment wouldn't have been possible without the generous help of many of the landowners along New Zealand's east coast. Thank you for letting us put one of these instruments on your lands.